Let us understand how a building is made. Deep in the soil, we build the foundation. Then we build the columns. Columns are the vertical components. Then we place horizontal components over the columns. This horizontal component is called as the beam. We can then place slabs over the beams. Let us place the furniture and the people. This structural unit is repeated to create the complete building. With this knowledge, we are in a position to understand the load transfer in the building. As seen here, the loads from the slab come over the beam. From the beam, the loads passes through the columns. And from the columns, the load goes into the foundation and then to the soil. Let us now focus on the beam. We can see that the beam is a horizontal component. This central line is called as the axis of the beam. The loads are applied perpendicular to the axis of the beam. The beam is placed over the columns. These columns act as supports. As the beam transfers its loads onto the supports in turn offer opposite forces, called as reaction. Consider a bar. Due to changes in temperature, the bar length increases or decreases freely. Now consider the same bar, but fixed at the both ends. Due to temperature changes, the bar cannot increase or decrease in length, because its ends are constrained. In this case, its behavior is similar to a bar, acted upon by forces at the ends. Thus, stresses are produced in the bar. Such stresses are called as temperature stress, because they occur due to temperature changes. If this support slides a little, we call it as yielding. If this support yield a little, then the temperature stress in the bar reduces. If this support is altogether removed, then there would be no temperature stress in the bar. Let the length of the bar be L, at a particular temperature. Then if the temperature increases by T degree, the bar length increases by this much amount. Here, the alpha is called as the coefficient of thermal expansion. And it depends on the material. If the ends of the bar are constrained, then stress produced in the bar is given by this formula. In case if the support yields by an amount A, then the stress produced in the bar is given as